Okay, there we go. So again, welcome everyone. This is the October COVES Community of Practice webinar. I'm really excited for you all to join us on this Tuesday, and especially excited to welcome my colleague, Dr. Jeremy Simon, who is the Senior Research and Evaluation Data Fellow at the Museum of Science. As was shared in the description of today's meeting, we're going to be talking about an exciting analysis we did of some Museum of Science specific COVES data that we think are going to be broadly applicable to all of you as we think about audience segmentation and some of the analyses we've done over the year. The presentation may run around 25-35 minutes, somewhere in that middle range. We encourage you to populate the chat with questions or thoughts as we go on, but we're hoping to open up the second half of this call to ideas about what you saw during the presentation, analyses you may have done on your own, or just thoughts and inquiries, broadly speaking, about how you can do this sort of thing with your own COVES data set. So with that, I'm going to mute myself, turn it over to Jeremy, and we'll let the presentation begin. Thanks.
Thanks, Ryan. Hello, everyone. Nice to meet you all. I'm going to share my screen and see what happens. Great. Do you see audience segmentation? I'm seeing 2 thumbs up from Ryan. That's as many as I think he has. So I think that means we can get started. I'm Jeremy Simon. I work at the Museum of Science. I have a background in psychology, not in museums at all. So this has been a fun adventure of 13 or 14 months so far. I actually work on the curriculum side at the museum. So Ryan has pulled me into this COVES stuff, and it's been a really nice step away from my day-to-day. And I'm really excited to get feedback from all of you, and you can tell me what's useful here, because I certainly don't know. But the basic idea, if this realizes it's on PowerPoint, there we go. Basic idea here is that we're trying to make sense out of complicated data, which you all know. The COVES survey is pretty long. We give it to a lot of people. And just letting the data sit there wouldn't be very helpful. So the goal is to do some sort of data reduction, some sort of data categorization, and to try to figure out who our audience is in 5 words or less, as it were, to try to find the most simple, straightforward way to describe who we're actually reaching, who our visitors are. So I think the goals in these analysis were generally to be able to categorize the audience in order to be able to say, oh, these people want this and these people want that. If we want to attract more people like X, we need to design experiences that appeal to them, but people in group Y probably need something else. And to also identify different use patterns, like some people are coming on the Friday evenings when the museum is open, some people are coming first thing 9 a.m. on Tuesday. It varies. And then secondarily, to be able to apply those categories, we can see, oh, if we've designed something with the goal of appealing to some category of people, well, can we see if that increases the number of those people who are coming to the museum? So we're looking just to categorize our audience. So the talk is in 3 parts, not really, it's kind of quick and dirty, but I want to tell you like what the museum was doing years in the past, which is something called cluster analysis, which I'll explain briefly in case anybody wants to use it, and to show you the cluster analysis that Ryan and I did and what we learned from it, and then kind of share what we decided at the end, which is to just instead segment our data. And since I think talks should try to get to the point is you can just cut your data based on simple variables and compare those groups based on those variables, and you can learn almost as much, if not more, as you can using a fancy pants cluster analysis. But we'll start with the fancy pants cluster analysis because who doesn't like fancy pants? So the background is years ago, I think, Ryan, correct me if I'm wrong, and of course jump in at any point, starting in like 2013 or so, using the precursive COVES, the VXM data, the museum hired somebody to do a cluster analysis to get audience segments of museum visitors. So that looks kind of like this. I think this is the last time it was done, was fiscal year 2016. And internally, this was kind of a beloved analysis. It was really useful to think about visitors to the museum in these kind of 4 categories that came out of the analysis. And they called them togetherness-oriented families, enrichment-oriented families, experience-driven adult duos, sightseeing groups. Obviously, there's these cool graphics that went with it. And it's just kind of nice and helpful to have these 4 groups that we could think of, the kind of 4 types of people who are coming to the museum. And so when I was brought on board, Ryan said, hey, we haven't done this in like 5 years, and there's been a pandemic. Can you check? Is this still the case? Can you recreate this analysis? And I said, maybe. And so I decided to give it a shot. And the technique is something called cluster analysis, statistical technique. It's actually technically a form of unsupervised learning in machine learning. So it's really, really fancy pants. But the basic intuition is just if we have some data, it might be useful to put it into categories. So you could imagine a data set that looked like this, that we've got two variables that were in. Can you see my cursor? Did I get a thumbs up, Ryan? Awesome. You've got data categorized on two variables, X and Y. And we want to say, well, are there different groups within this data? You can use an algorithm. The most popular one is called k-means. And then you can say, actually, these data sort into three categories. Well, this isn't a very interesting example because you and I can look at these fake data and we can tell you, oh, there should be three categories there. But you can get the basic intuition that, okay, the idea is to find the groups such that the distance between the dots is smallest within categories and biggest between categories, right? But a computer can do this not just on 2 dimensions, but it could do it on 50 dimensions, and it can do it with thousands of rows of data, which our brains just aren't set up to do. There's no way that you or I could look at a giant, like a full COVES data set and say this goes into this many categories, which is why we get the machine to do it. There's pros and cons to this approach. One thing I like about it is that it's data-driven. So you might have a hunch that there's a real big difference between the right-handed and the left-handed people coming to the museum, and you might want to like split all your data that way. Well, if you have the data on that, the cluster analysis will tell you whether or not that's actually a meaningful variable, right? It's just going to pull out where the differences are. It's not going to take into account your hypothesis, but maybe you don't have a hypothesis, in which case it's very nice to just have the data tell you something. And as I said, it's really nice for getting complicated patterns. Like going into it, especially me being new to this museum space, I didn't really have any idea what I'd find, and I didn't have any way of looking at the many, many variables in COVES data and trying to figure out what would hang with what. And of course, it's fancy, and it's who doesn't love to just impress all their friends at their cocktail parties or their Zoom cocktail parties. I assume most museum people spend all their time at cocktail parties. I don't really know. The cons, well, it's for one thing, it's like a technical point, but it's not at all robust to missing data. You can't have any missing data in any rows to run a cluster analysis. So you have to impute it or you have to take it out of your data. And generally the people who are leaving things blank on your COVES survey might have systematic difference from the people who aren't, and you're going to lose them in your analysis. And so just a technical point. It's also hard to interpret, right? This is your best case scenario, that it's like very clearly three groups. More likely, you have to tell the cluster analysis to draw a certain number of distinctions, and it's going to draw those distinctions. Whether they're meaningful, I mean, they're meaningful in some mathematical sense, but if they're meaningful in the real world, is kind of up to you. And then you have to put a label on it and share it back to your organization and make meaning of it for everyone. Sometimes that's easy to do, sometimes it's really arbitrary. And it requires a large sample. You're not going to do this with a few dozen data points, you need hundreds. So just to kind of get a sense of the pros and cons, what we're talking about with this analysis, I'll quickly walk you through the procedure. Again, the point of this talk is not to tell you to do this analysis. The point is almost the opposite, to tell you not to do this analysis, but Ryan and I did it for you so we can kind of share what we learned, but we want to have a sense of what was involved. I'll also say all the analysis and all the figures I'm showing you are done in R. I am happy to share code. That code is not in a particularly public format right now, but please reach out to me. My email will be on the final slide. It's jsimon@mos.org. We can figure something out. I'm happy to comment the code more or make it more user-friendly, or just send you the garbage that I have right now. It's sort of up to you. Mileage may vary. But the most important thing in any kind of cluster analysis, I think should I ignore chat till the end? Oh, thank you, Allison. The most important step is choosing what variables to put in the analysis. In machine learning, we call them features because, of course, we need a different nomenclature for everything. That's which questions from the COVES survey do you want to use to split up your data, to categorize your data with. And what you choose is going to make a big difference to what differences come out in the analysis. Here is what we used, which is mostly based on the previous analysis that was done back in 2016, trying to use the same variables as in that analysis. We also had to take into account which variables have more missing data. We had to omit some variables because we just had too many people not answering those questions, or we couldn't use any questions that had been added in during the time period that we were looking at, because then we wouldn't have responses from everybody in the data set. But so there's that set of motivation questions. Ryan can correct me. I think it's like 6 of them or 8 of them, which is like, why did you come to the museum? And you have to choose 2. It could be fun for yourself or fun for your group. It could be education for yourself, education for your group. It could be to see a show. So those are binary variables, and those are all in there. We included group size, a binary variable for whether a group was adults only or had children in it, whether they were members or non-members. Last visit, frequency of visit, latest stay, day of the week, season of year, where they're from, were these binary variables, either you're from the greater Boston area or not, or you're from the state of Massachusetts or not, and then whether a group was locals, out-of-towners, or both. So those are what we're using to categorize our audience. And that's arbitrary, and I'd love to hear people's thoughts on what should or shouldn't be included for categorizing audiences. We had to scale the variables. This is just if you have any values in your data set that are kind of on a different order of magnitude. So there's people who say they visited the museum 100 times. If the scale variable goes from 1 to 100, that's going to kind of wash everything out of the analysis if everything else is like a 0 to 1 variable. So you just scale it or you can z-score it. Again, you have to deal with missing data. It's pretty hard to impute data that's got as many categorical variables as we have. So we just went with list-wise deletion because it was a big data set. We deleted any row that had missing data in it. We still end up from this 4-year period with 5,200 visitors. The initial data was over 7,000, so almost a quarter of the data had to be removed. Again, that's why I'm saying there are drawbacks to this form of analysis. And we initially ran the clustering just on this pre-COVID data. We looked at each of the years individually, the fiscal years individually, decided there weren't really big differences, and kind of ran on the full sample. If you choose an algorithm and a distance metric, I am not an expert in this. I did a little bit of reading to choose these. It looks like you want something that's median-based rather than mean-based when you have a bunch of binary variables in the mix. Again, cluster analysis is looking at the distance between the data points in higher dimensional space. So you need some sort of way of measuring that distance. Euclidean probably isn't up to it. Some dude named Goward invented one in the 70s that people recommend. It's all implemented in R, so it's very easy. There's lots of blog posts, happy to send them. Again, I wouldn't stake my professional name on this being the absolute best way of performing this analysis, but you got to choose something. So be warned, that part gets extremely technical. And then the number of clusters in a cluster analysis, it depends on your algorithm, but most of them are agnostic. You just tell it, I want X number of clusters, and it'll give you that many. And it's up to you to decide if they're meaningful. So there are some ways to quantify the best number of clusters to use. The one we use is called silhouette indices. And that's just a measure of how distinct clusters are. So ideally you want more distinct clusters because it means that there's bigger differences between the types of people who are found in them. Maximally distinct clusters would be every dot by itself, but that would obviously not tell you anything. So you're balancing the distinctness of the clusters with whether it's a number of clusters that you can then bring to your organization and say, hey, we have 4 different kinds of people, that's maybe useful. Hey, we have 15 kinds of people, not so useful. So there's a bit of a choice there on the analyst side. And then you just assign the data to the clusters. You say, okay, row 1 is in cluster 1, row 2 is cluster 2, etc. So let me show you what that looks like for us for this 2016 to 2020 data set. These are technically called medoids. These are like the prototypical members. So these are actual rows in the data that are like the center place in each cluster. And remember, it's a center across the like 20 different variables. So this is a lot of numbers to put on screen. Let me draw your attention to a few things. We have 2 clusters where they are mostly members, where the prototypical row in the cluster is a member of the museum. We have a couple of clusters where the prototypical member is from out of town, not from Boston, not from Massachusetts. And then we have a couple where it's an adult-only group. There aren't any children in the group. And you can quickly, and looking through this, you can kind of see some differences quickly. Members have been to the museum recently, like last visit less than 3 months ago, whereas the out-of-towners more than 10 years ago or never. Groups that are adults only seem to have slightly lower amounts of time spent in the museum. They're younger. So you can start to see how there is some value in this, right? You can see that there are some clear differences between these groups that might help us make decisions. but it's a cluster analysis. So like these are the prototypical members, but the clusters themselves look more like this, where we have a cluster here and 91% of that cluster are members. 80% of that cluster are from the greater Boston area. 10% are adult only. So 90% of them have children with them when they're answering the COVES survey. And we still have 6 of these groups, and you see 2 of these groups tend to be members, 4 of these groups tend to be local, 2 of these groups tend to be only adults. And then we can dive into, and again, this is kind of too much to take in quickly, but we can see that motivations differ. So the reason that there's 2 member groups is that this group is almost entirely members who said they came to spend time together, whereas this group is more likely to say they came because they wanted to have fun for their group or they wanted to see a show. We have 2 groups that are mostly adults, but one of those groups is kind of local and one of those groups is much less likely to be local. We could spend all day kind of staring at this data, but the 2 points I want to make: one, there do seem to be real differences between these clusters. It's picking up differences in the types of people who are coming to the museum, but it's kind of imperfect, right? So we're calling, this is clearly groups that are mostly members, but it's 91%, it's 86%. These are groups that are mostly only adults, but it's 84% and 73%. It's not every single person is only an adult. There's something else complicated and higher dimensional that's going on. So there's issues with this kind of analysis. One is that it's an arbitrary number. We presented it to leadership and they were like, 6? Does it have to be 6? 6 is too many. Can you make it 5? Can you make it 4? And we're like, yes, maybe. And then naming the clusters was a point of contention too. We got a lot of like, well, what are they called? And I was like, well, I could just give you these, and that's not very helpful. Okay, I give them names. So I gave them names, and it's like, okay, we've got the frequent flying members, we've got togetherness oriented members, because if you look back, sorry, here, these people really want to spend time together, so they're togetherness oriented, I guess. There's local families, there's local adults, there's adult tourists, there's family tourists, where adult here means doesn't have kids with them, and tourist here means from outside the greater Boston area. Like, it sort of describes what's going on, but again, it's pretty imperfect because only 90% of these groups are members, and only, some percentage of these adult-only groups are actually only adults. And maybe the biggest issue we had is it doesn't carry over well to other data. So we wanted to look at post-COVID data. The museum closed for a few months in 2020. It reopened in July 2020. We have now 2 years of data in this COVID world. And we wanted to see, like, does the composition of people coming to the museum look different than it did beforehand? And so you can actually apply clusters forward. It's annoying, but you can do it. And what we found was that none of our attendees, none of our COVES survey respondents since July 2020 got categorized as adult tourists. And I checked and rechecked that, but all it's doing is it's taking these like prototypical values that I showed you and placing them in the new data set and saying who's closest to those clusters. And no one was close to the adult tourists. So it just wasn't a good way to categorize the new data. When I ran a totally new cluster analysis on the new data, it was like, you should have 2 clusters. And I was like, that's not helpful. We have members and non-members, and there's better ways to get at that, which brings me to what next? So talking to Ryan, we realized, what if we just segmented the data? What if we just said there's members and there's non-members, and we can compare those 2? And there's people local and people who aren't local, and we can compare those 2. And there's people who come with their kids and people who don't, and that we can just compare those 2. And when you do that, you can start finding interesting things. So here's now all the data since 2016, because there's no problem. Like we've included those variables in all our surveys since then, and we can just easily take the whole data set and split it into members and non-members, or split it into groups with adults and groups with kids, groups that are from Massachusetts or not from Massachusetts. And I don't know, I mean, these are, like, we haven't dug deeply into these data. I should say these are rolling averages, because COVES data is pretty bouncy. Like if I get 3 people and they're all members on one given day, then it looks like I've got 100% only members coming to the museum that day, right? So it's not like, these aren't attendance metrics. And this doesn't, it's a proportion. So if, in July 2019, we have twice as many people coming to the museum than in July 2020, that's not reflected here, but it's just the relative proportions of members to non-members, et cetera. it's interesting. It looks like membership is members are a higher percentage of our audience during the kind of peak of the pandemic, and that's been steadily tailing off since. Might be food for thought, and way, way easier than running a whole cluster analysis. So just to show you a few other things that kind of looked interesting, when we segment by member, here's Net Promoter Score. So the members' Net Promoter Score is a 78, the non-members is a 64. This is a mosaic plot, which you don't see very often, but I love. It's a way of visualizing two categorical variables at the same time. So here the x-axis is whether you're a member or non-member. So the width of these columns tells you the proportion in the whole sample of members versus non-members. You can see it's like, call it 60% non-members to 40% members. And then the y-axis, you can see the proportion in each of the categories. So you can see very easily that members are more likely to be promoters than non-members are. Non-members are more likely to be detractors. So that's maybe not surprising, but nice to see confirmation that members like the museum. You can see that members are much more likely to come back multiple times. So most of these non-members answering the survey came to the museum once, which probably makes sense. But again, nice to be able to kind of split up the data and start to see differences in our audience. We can compare the groups that are only adults and the groups that have kids with them. Groups with kids spend more time in the museum. And I should say all the, actually, I got nerdy and I checked. All the differences I'm showing you here are statistically significant at p less than 0.001. They're like really clear differences. Also the sample's like 11,000 people, so it's easy to find these differences. But yeah, groups of kids are spending 3.5 hours in the museum. Adult only groups are spending under 3 hours in the museum. That's interesting. Probably provide some more things for people who are spending longer in the museum. When we ask these motivation questions, again, you're choosing 2 out of the set of reasons for your visit. Can see that we've got more groups with kids than groups that are only adults, and that most people are not saying they're coming for their group to have fun, but groups with kids are much more likely to say they're coming to have fun with a group than adult only groups. And groups with kids are less likely to say that they came to see a show than groups that are adults only, even though most people aren't coming to see a show. Might be interesting for people planning shows to know that. And then we can do the same thing. Here's a more complicated mosaic plot. So people from Massachusetts versus not from Massachusetts. The majority are from Massachusetts, and the plurality of people from Massachusetts had been to the museum within the prior 3 months, whereas the plurality of people who aren't from Massachusetts had never been to the museum before. Right? We get a sense, it makes sense, right? It's not earth-shattering to think that locals are more likely to come to the museum more often, but here's a pretty clear demonstration of that. And why are they coming? Well, it looks like people from Massachusetts are more likely to come so their group can have fun, and they're more likely to come for a show. Again, it's probably what you'd expect, but just being able to split the data this way is kind of nice. And then I should have broken this slide into pieces. Sorry, it's again throwing a million numbers at you. This is splitting up into all 8 combinations of these segments. So we've got 4 groups that are adult only, meaning they don't have any kids with them, and 4 groups that are families, so groups that have kids with them. We've got 4 groups that are from Massachusetts and 4 groups that are not from Massachusetts. And then we have 4 groups that are members, right? So we've taken these 3 ways of segmenting the data, we've combined them to get all 8 possible groups. And when you do that, you can see like the percent of our audience. So it seems like the core of our audience, the plurality of our audience, are members from Massachusetts who bring kids to the museum. That makes sense, right? Local people who are members of the museum, repeat customers, bringing their kids. If you're going to survey people on a daily basis, this is who you're going to find is coming to the museum. Not a lot of adult members just showing up, no kids, members of the museum. Adults are much more likely to not be members. And obviously, people who aren't from Massachusetts are much less likely to be members. It's only 1% of the people we're surveying who are members without kids coming from out of state. But then you can look into all these motivations for being there, and you see, well, families are much more likely to be there because they want to spend time together than groups that don't have kids. Families are much more likely to be there because they want their group to have fun, and way more likely to be there because they want to educate the group. Right? There's a very clear divide in the motivations for groups with children and groups without. And there's a whole bunch, like adult members from Massachusetts are much more likely to be dropping in just for a show. We'd probably suspect this, but it's really nice to just be able to kind of like have some clear variables with which to break down the data, since there's a lot of it. And yes, it was really helpful to have run a cluster analysis because it gives me a lot of confidence in choosing these ways of segmenting the data. But I'm the outsider coming into this field. For you all, you know your museums, you know your data sets. I'm sure you can think of, I mean, these are probably useful variables for you, but you can also choose your own ways of splitting up the data. The last plot I'll show you is this, which is again a rolling average of the proportion of the COVES respondents in all of these groups, so all 8 groups. And what's really clear here is that this kind of core group of family members from Massachusetts, so groups with kids coming from the area who are members of the museum, really into the peak of the pandemic becomes a larger and larger segment of the people who are showing up at the museum. And that has been dropping off dramatically, which probably doesn't mean that there's a lot fewer of those people coming, because I think the number of people attending the museum has been rising as people feel safer being out in public. But it means that as a proportion of all the people coming to the museum, fewer and fewer of this core group, and we're seeing these other groups picking up instead. And I will stop there in case there are any questions. And actually, I think it's probably best to stop sharing my screen, so I'll say thanks. Here's my, my email, which Allison put in the chat.
Wonderful. Thanks so much, Jeremy. And I'll just chime in before we get started with the questions and responses and feedback and stuff by giving kind of my takeaway on when I asked Jeremy to work on this with me. It's obviously complex, right? There were charts in there that were that make you got to look hard and deep at to kind of make sense of. But at the end of the day, this is really a decision-making mechanism. So Jeremy is advocating for the simplistic segmenting your data by using specific variables approach as opposed to the cluster analysis. I've talked about cluster analysis with this community before. We've shown those the cluster results, which we called audience segments from years ago, with this community before. And those have been really useful. And I want to emphasize that one of the reasons we're moving away from that cluster analysis is because of the difficulty / nearly impossible ability to replicate those clusters over time. So essentially, when you use new data within the clustering algorithm, what Jeremy called the medioids or the centers of those clusters literally move because there's new data in there, even if it's the same survey, even if it's the same variables. So once we had traction with those audience segments and we tried to quote unquote update, right? People kept asking for updated audience segments, percentages and information. It became harder and harder to do so over time with the statistical reliability that we needed to ensure we were doing a good job of discussing our audiences. And because of that, it didn't make sense to keep doing. So when we talk about use cases moving forward, even though there are now 8, right, 2 to the 3rd power, because we have 2 variables that are binary, members, locals, groups of kids, we now have the ability to do that over and over and over and over and over forever, as long as we ask questions about membership, get group composition, and ask some kind of geographic variable. And so now we readily have this ability to focus on the proportion of people who fall into any of those categories and discuss every other aspect of the COVES survey with regard to that audience segment. So there's a distinct reason why we moved away from the clustering and a distinct ability to advocate for the segmentation proposal moving forward. And that's what we were trying to highlight through this today. Okay, so with that, if you've got comments, questions, thoughts, strong reactions against what we just proposed, we'd love to hear them. Jeremy and I are always open for a rowdy debate. As he said, he likes to wear his fancy pants and he imagines that we all go to galas on Zoom. I think that's what he implied.
I don't have any data, so I'm just guessing.
Right.
I'm wearing khakis for the record. There's a question from Kate in the chat. I'm curious to hear your answer to it, Ryan.
Yes, just curious, was there anything surprising in this cluster analysis exercise that you think you wouldn't have noticed otherwise? Well, I would say that the reason we were able to highlight members, locals, and groups with kids was because we ran the clustering analysis to say that those were the variables that pushed the clusters apart. Those tended to be the meaningful variables in our clustering algorithm, even though just to use a bad phrase, we threw the kitchen sink in. We threw as many variables as we could at first to see what came out as meaningful in driving those clusters apart. So that was important in where we ended up as far as next steps. And of course, just the academic exercise of going through the cluster analysis is always surprising. If you haven't done it before and you're interested, it'll change your life, maybe for the worse, but still.
Definitely for the worse. The one thing I'll add, I didn't show it on the slides, but there was a difference between groups on days of the week that they came to museum. And so one of the things that differentiated, I think, the two member groups in the cluster analysis with 6 clusters was that one group was coming on weekends and one group was coming Monday to Thursday. I mean, we didn't just like throw all 7 days in as equal opportunity. We kind of split it into Monday through Thursday, Friday, and then Saturday, Sunday. And there's like a difference between people who are coming Monday to Thursday than on the weekend. And maybe someday we'll dive into what that difference is.
And that's great to know because 2 things. One, even with our segmented approach rather than a cluster analysis approach, we can descriptively look at who's coming when using those same variables. And 2, this is all the more reason why we talk about that random sampling approach when we talk about changing the days of the week and the times of the day, knowing your audience. If you just limited it to 1 or 2 days a week, you might be missing this ability to detect core differences between segments. All right, Lauren, something handy about the clusters is the simplicity of the personas. Filtered by several variables is simpler on our end, but more complicated to describe in passing. Any thoughts on utility, adoption to referencing these groups with current approach specificity? So I agree, the personas or the labels that we gave to the clusters was really helpful when we first developed the clusters. And it became increasingly problematic over time for 2 reasons. One, when we talk about sightseeing adult duos and 10% of them come with kids or 20% of them being local, you break your own persona, right? Even if you've done literally a persona approach and you can talk like Jeremy did about this one case embodies this cluster, it's not true that all of the people who fit into all the visiting groups that are assigned to that cluster actually fit the persona that you're using. So that tends to cause some headaches when you're fully explaining the data in an analysis. And secondly, again, it shifts over time. So once you've got traction with any kind of persona, or in our case, labels of the clusters, and those started to shift, if 0% of our audience fell into one cluster because the data had moved, and we introduced a new cluster or a new persona, it's basically this rebranding process all over again. Why did the clusters change? Do you even know what you're doing, right? And questions came back to our ability to do the analysis of our own data. And so we really said, like, we know what we're doing. It's the clustering approach that is imperfect for our use of the COVES data. So yeah, 8 segments is much harder to talk about, but breaking it up by 3 variables, 3 known correlated variables, is much easier for us when doing descriptive analysis, which is 99% of our work anyway. Those are my thoughts. I'm not sure if you have any more, Jeremy.
Yeah, I second what you said. I think, this is something I'd love to get feedback from everyone on, is I think we're still at the point of like, okay, we've reached this realization now. How are we going to use it? How are we going to bring it forward? Because it's really easy to create, like, I can create like an exploratory dashboard and you can go through and have these tables with all the variables and see the differences and play with it. But to give something that's explanatory, to give something that's quick and easy to understand, I agree with you. Like, having the personas is really nice. My thinking right now is pick and choose, right? I'm looking at this table. You can't see it, but I can. And like, you can take out 3 of the 8 categories and only lose 9% of the data, 10% of the data. Just make the personas out of segments instead of cluster. You're already losing a bunch of data when you do a cluster analysis anyway. So why not just lose the data from the segmentation? At least when I say they're adults, they're actually adults and they're not bringing kids with them.
Yeah. Hey, Jeremy, is it possible to identify like a prototypical case from the segments? I bet it would be.
Yeah.
So in that sense, we could recreate a pseudo persona using real data to then kind of map behaviors onto based on those segments. So yeah, I think that's a good approach. Maybe it's a hybrid between the old and the new, as Lauren is suggesting, the helpfulness of having those labels, anchors, personas, whatever. Okay, Kelsey's asking, since you used the cluster analysis to eventually get to the groups you wanted to segment by, what would you suggest we do to get those groups? Possibly finding significant differences in NPS scores between groups. So, Kelsey, that's a great suggestion. And in fact, this is something I meant to ask our full community because we've got a much broader audience here. Remember that this is the Museum of Science data. So we're thinking about the Science Museum perspective here. The Art Museum instrument changes just a little bit, particularly in the motivations, but also known differences, with or without data on who attends is important. So I would say that for other science museums, maybe large science museums, following our procedure directly is a great starting point. I don't have any reason to suggest that there's a reason to do another cluster analysis to get at your variables that would segment your data better. I'm not confident that the same approach, just segmenting by member, local or non-local, and groups of kids, would be sufficient for art museums, because I don't know that those three variables are the ones that would distinguish clusters in a potential cluster analysis. I also think that there's lots of subgroups that likely demonstrate NPS score differences, and we haven't fully explored that, and I think that's largely contextual as well. And we could do an entire COP series probably on where we're finding differences in Net Promoter Scores. So that's not how we determine the member non-member piece to be relevant. Again, it was not in pushing apart NPS, it was in pushing apart full clusters of audience based on demographics, motivations, visit history, etc.
I will add that there's a distinction that I didn't get into in talking about this. There's the variables that I used as features, the variables that fed into the analysis and that the computer used to differentiate audiences. But then I also used those clusters to look descriptively at other variables. So I didn't use demographic variables to distinguish audience. I didn't use NPS or OER to distinguish audiences, but there are differences on those if you look across the clusters. So you might want to split people by their NPS score just straight up, or you might want to split people by demographics. That's no longer a data-driven approach. That's like you've got a specific hypothesis, but I think that's probably a really valuable way of segmenting your data.
Yeah, Tom, great question about how these results have been put to use at MOS, informing marketer programming. So I'll jump way back to the beginning, the fancy version of the audience segments that you saw, right? The infographic style was literally used for marketing and programming back when we developed it. We used to talk about making sure that exhibits were accessible to all of our audience segments. We used to talk about reaching out, right? Marketing externally to all of our audience segments and keeping those proportions in mind on a year-to-year basis. This represents 40% of our audience. This is only 15% of our audience, etc. But we talked about it as if it were the entirety of our audience, knowing that the cluster analysis was a flawed procedure, and we literally threw out a quarter to a third of the data in order to get there, and that each were imperfect in their own right. But because we got so much traction around this idea, I'll use Lauren's words of personas, right? We had these fixed names. We had infographics up in cubes in offices. We could use it for a lot of different mechanisms across the museum. When we didn't replicate it over time because of the difficulty and capacity issues, the old clusters continue to be used, but of course, that piece of paper on the cubicle wall gathers dust, and if I'm not presenting it, it becomes less readily helpful in thinking or planning. And so now in this new strategic approach, we're trying to take a step back and say, actually, how do we want to use the data? Is it worth it to do this clustering imperfect procedure? Or if we can just say, no, we've got full audience data from our COVES data set, and this is how we suggest analyzing it moving forward. How do you, as senior leaders, as marketers, as educational programmers, want to use this? And one of the key ways that you can do it, as Jeremy was just describing, is within each of those or any of those segments, you can kind of run descriptives on who is seeing what, who is doing what, who is coming for what reason. which enables you to get a more nuanced look at some of the educational side of things, visitation side of things, less so from a marketing perspective, because even if you think about that last graph that Jeremy showed of all 8 audience segments and kind of the tailing off orange line of our local family groups with kids, keeping in mind that that's a moving average, a floating average, that's bound to change over time. So even if you did nothing different from an educational or marketing perspective, when class is in session, when school's in session versus the summer months, all of these pieces will impact your ability to see who was in the building at what time. So there can be a lot of different ways it can be used. Again, it was very heavily used when we first developed it. And so I think for anyone who's not done this approach before, just doing it the first time and sharing these results would be hugely informative, especially from a segmented approach rather than clustering approach, because you could talk about how we want to use the data internally. I feel like I'm doing a lot of talking. Okay, another question in the chat. Would COVES be open to conducting a cluster analysis for any other types of museums using the broader COVES dataset? That is a tricky question, Julie. Thank you for asking. I know you had to do it. I'm sure you didn't want to, right? And it's a great suggestion that we'll have to explore down the road. As we know, this is a time-consuming procedure, and it involves a lot of subjective decisions throughout the process, what variables or features to include, how to interpret them, what's the right number of clusters, for whom and to what end. So doing it for the museum made sense because we could make those decisions, but doing it on behalf of multiple museums, we may be missing patterns. We may be missing distinctions between museums that are really meaningful. So it gets much more complicated when you expand the unit of analysis. That makes me a little tentative.
Also computationally intensive. Just on a practical level, these were slow to run with one museum of data.
Yeah. But that doesn't mean it's out of the question. And certainly as more museums consider this type of work, using like a case study approach, partnering with someone might make a lot more sense than just saying, we're going to run it for all small museums. That gets harder, much harder. Okay, Claire's asking, how do we download our raw data in order to be able to do this type of segmentation? Or are we able to do the segmentation through your dashboard? Great question, Claire, and I can offer multiple answers. So to download your raw data, you can access your Dropbox folder. Every single institution, art, science, children's, natural history, Art Bridges, any of the COVES participants have a unique location on the web where you can download your raw data. It's actually been cleaned from the survey so that you have some imputed variables or some cleaned up form of the data that we collect. And you can download it in a CSV file, which you can use in Excel, which you can use in R. And we also provide an SAV file for SPSS users. So that's the first step in getting the data onto your machine and starting to poke it more personally, if that's not an inappropriate reference. And secondly, can you do the segmentation through your dashboard? Yes, you can. The important thing about moving away from a clustering analysis, if you're just looking at kind of splitting these differences, is by a combination of filters on your dashboard, you can create these 8 audience segments by doing member, non-member, local, non-local, groups with kids, non-groups with kids. All of those are clickable widgets on your dashboard, and you can save them as well. So you could save the 8 permutations, combinations. One is order dependent. Okay, great. You can save all 8 of these filters on your dashboard to kind of look at these independently. The first step is probably just doing one at a time, member, non-member, local, non-local, groups with kids, groups with no kids, and then trying the different combinations, because you will figure out pretty quickly where the big differences are and which ones you want to pay attention to. As Jeremy mentioned, for us, we could eliminate 3 of those segments and only lose about 10% of the data, which means we simplify our lens and still are capturing 90% of our known audiences. And Allison is helpfully reminding people that you can just send us a note to coves@mos.org for any questions about how to access your data or how to set those filters on the dashboard. So I'm really curious if anyone else has started going down this path, segmenting maybe, again, just by one or two variables on a regular basis, or if you've tried a clustering approach or any other type of analytical approach that allows you to, again, reduce your data or simplify in any way. I know for a fact I've shared our clustering syntax prior to this experience with some institutions. I just can't remember with whom or how long ago or what came of it. Maybe nothing. All right, well, for you all, how might this be helpful moving forward? I mean, I think Claire's question was direct and to the point. How can I do this with my data, right? Where can I get my data? And then how do I do this on the dashboard? And there are direct approaches. But how else might this be helpful? Or if Jeremy and I are going to continue banging our heads, and trying to make sense of this and do something else that's geeky but useful, where should we invest our efforts? Of course, just saying we did it perfectly the first time is fine. It's, we're used to that.
Oh, sorry, I'm jumping in. I want to say thank you so much. This is super, super helpful for us to kind of have the point of reference of somebody that's gone through both processes and come to the simple, easy way, which is amazing, and having some justification for it. I'm excited about it. We haven't done really very much attending to our demographic data at all. And I think it is a place that's ripe for consideration. So this is a good inspiration, but I'm also curious, like I know you picked 3 to kind of focus on, but are there other areas that you guys are curious about diving in with? And like, where do you hit that point of analysis paralysis? If there's so many ways we could split this stuff up. Did some of that come from your clustering?
Yeah, I mean, my first response is to steal a word that Jeremy, or a phrase that Jeremy used earlier, which, it's actually, I'm not going to steal it if I can't remember what you said. It had something to do with like, this is no longer statistics, this is a hypothesis, or, like we're moving away from a rigorous approach to statistically analyzing the data to simply like acting on a hunch. And I would argue that those hunches, so if we move away from the 3 variables that Jeremy and I are focused on or recommending for segmentation, I think that splitting the data by any reasonable attribute of your visitors is worth exploring, because there's no right or wrong answer. Now, you may simply be seeing an artifact of chance, depending on the window, right, the time duration of surveys that you're looking at, or the amount of data in that sample. But over time, all of us have a lot of data. You have a lot of statistical power. And so splitting once and looking at differences across everything else that's not that one data point could be hugely informative, if only to say, whoa, that's surprising. Let's keep our eye on that. And if that trend continues over time, it stops to be just a trend. It starts to be a meaningful or statistical difference that is worth monitoring forever and ever, or at least until we identify the root cause of it. So I don't know that I have specific areas for people to explore, but I would say that nothing is off limits. Keeping in mind that splitting the data by one variable is just that, until you put some parameters around it to say, okay, I'm going to use a data set of at least this much, or each subgroup has to have a sample size of this much, and the effect size that we're looking for is only this much if we're comparing 2 things. So,
One thing I'll add, which is unfortunately a little bit of a pro cluster analysis response, is the cluster analysis was nice in that it really built my confidence in those specific variables. And the reason is that one reason that it did is that it shows what hangs with them. And sometimes that's surprising. So like education is one that really comes out, like, and age as well. So the adult groups, the groups that don't bring kids, tend to be younger and they tend to be less educated because they're younger. And if I was just kind of looking at the data set and playing with different segmentations, I might not think, I might not realize that those variables are tied to whether people are coming with kids, but they are. And so we need to keep that in mind when we're drawing conclusions about differences between people with different amounts of education or differences between ages. But I think for the most part, I was surprised that there weren't other things that were popping out at me. And I feel good about those three, but again, as Ryan said, like your context is going to be pretty different and might not be the right ones.
Other questions or thoughts? You're allowed to ask multiple questions, even if you've posed a question in the chat or spoken up.
Yeah, I'm still processing all of this, but it's really cool. I'm like sitting there thinking about what kind of groups might emerge for the art museum setting that would be a little bit different and all that. So lots to stew on.
Yeah, I agree. I'm most interested in pushing this over to the art museum side because I don't think that the groups with kids piece is going to be as meaningful. Anybody who has a membership program, I mean, it's a no-brainer for me. The two groups just function differently and clearly have correlated variables that will also distinguish potential clusters, even if we don't call it a cluster analysis because we're doing a segmentation. Yes, Jeremy, I think if you're willing, we'd be happy to share the slides. I will confess, as I have 100 times, and this is a capacity issue for us, like it would be really cool to do a more thorough write-up of this. Jeremy and I have talked about writing this up more sophisticated for consumption, and we will as time allows, when time allows. So I'm not sure when that will be. But we want people to be able to benefit from this and say, great, I can learn from the experiences, I can replicate part of this as I'm able, or I can just jump straight to the conclusion and try and apply that myself. That's our goal for this. And this was the first step towards that goal of just sharing what we know, sharing the slides, allowing you to ask questions, and then kind of building off it from there. You're not wrong, Tom. You're not wrong. Okay, last 2 minutes. Last chance. Yes, Julie.
Yeah, I was just gonna say I'm super pumped about the art museum motivation question that we added at the beginning of the year, because I think that those motivations, and although there are like 1,000 of them, they do cluster under, like, maybe I shouldn't misuse that word in this convening, but and they do have larger themes, maybe under 5 different categories, I think. And so I've already done some playing around with that question and just thinking about like how people from far away are more likely to come here because of the popularity and brand piece, and people from near are more motivated by those community and social answers. So I just shout out to art museums, really think about those questions. And I don't know if we've shared with art museums how they how those all of the items cluster under the larger themes, Ryan, but if y'all want to send that out to the art museum group again, just so they have it handy, or we can send it to Art Bridges sites, but I know there are a few other art museums. I think that question is going to be fun for when I have a full year of data with it.
Yeah, agreed.
And I'm happy to share back whatever we do.
Sounds like a future COP right there. Straight from the mouth of Julie Goss. Okay, awesome. Well, I'm glad to hear this has been cool and helpful and thought-provoking, or at least I hope it has. I appreciate those of you who have contributed questions or comments in the chat. I want to thank Jeremy again, 1, for the analysis, 2, for being willing to present and share all this wonderful stuff with us. It can be technical, it can be kind of heavy, but it's also really insightful when you get down to the end of it. So I'm thankful for your work, Jeremy. I'm thankful for your contributions to the COP. I'm thankful for all of you for spending another hour with us on our Community of Practice webinar. And again, because this is recorded, we'll be posting this to YouTube. So please do recommend to your colleagues, if you think they'd get any kind of insight from this, to check it out. Otherwise, it's great seeing you all. Have a good Tuesday. And we'll be back in touch about next month's Community of Practice call soon. Take care, everyone.